We've been talking about supersaturated solutions, and we discussed rock candy and how you can make a supersaturated solution of sugar, but over time that extra dissolved sugar will slowly crystallize out and form that candy. However, it takes quite a while. Even when I do my special method with the sugar and I put some sugar crystals on the string in the rock candy, it still takes a matter of hours for it to happen. The absolute best supersaturated solution you can get is sodium acetate. Sodium acetate dissolves in water to the tune of about 90 grams of sodium acetate to every 10 grams of water. So it's extremely soluble in hot water. So you heat the water up to maybe 80 degrees Celsius, you can dissolve a lot of sodium acetate. When the solution cools back to room temperature, all that extra solid should crystallize out, but it doesn't. These are solutions of sodium acetate, all supersaturated solutions. They are very stable, unlike sugar, which after a week or two will begin to crystallize no matter what you do. Sodium acetate, as far as I can tell, is permanently stable. I last used these test tubes back in May. It's now the end of October. It's almost November. And these have been sitting in my cupboard since then, and they will probably continue to sit there for as long as I want. So let's take a look at what happens if we add a crystal of sodium acetate to one of these test tubes. I'm going to take one little crystal here on my finger, and let's drop it in that liquid. The instant we do that, the sodium acetate begins to solidify. It is crystallizing so quickly, the liquid can't even run out of the tube. Sometimes if you get a little air bubble to go up there, it'll start crystallizing from the top. But eventually, that entire tube is going to solidify. Now, based on the things we've been talking about in chapter 15, what's the one word we would use to describe this process? Answer, of course, should be spontaneous. This process occurred spontaneously. I always ask my students at this point in time to tell me what the test tube feels like. Is it warmer than it started? Is it colder? Or is the temperature the same? Why don't you guys think to yourselves, what do you think has happened to the temperature? Has it gotten hotter, colder, or has it remained the same? I can tell you that the most popular answer I get is that the test tube has become colder. And that's because it looks like ice. It looks like it froze. But if you think about it in terms of energy and entropy. Entropy does not like this process because it formed a solid from a liquid. So entropy is going to say thumbs down. Yet it happened anyway. The only way this could be spontaneous is if somebody wanted it to happen, and that somebody has to be energy. So the only way that this could occur spontaneously and have entropy decrease is if energy is released. And I can tell you that this test tube is very, very warm. It's quite toasty. They use this same solution in chemical hot packs that hunters and such use, and fishermen when they're out in the cold, they want to warm their hands and feet up. You put a little plastic pouch of this in your gloves or your socks, and when it solidifies, it produces a lot of heat. Let's go ahead now and see if we can actually measure this temperature change as the solution solidifies. As you can see, before we've added a crystal to a fresh test tube of the supersaturated solution, the temperature on the thermometer is about 22 degrees Celsius. And the test tube, of course, should be at the same temperature because it's been sitting in the cupboard for the last 6 months or so. Let's go ahead now and put the thermometer into the solution and add a crystal. All right, let's go ahead and add a crystal to the test tube and see what happens to the temperature. As you can see, the crystals immediately begin to form in the test tube. As soon as the crystals reach the bulb of the thermometer, we should see an increase in temperature. And there it goes. The temperature begins to rise very rapidly. There's 35. Now it's reached 40 degrees. There's 45. And we're closing in on 50 degrees. So that's about the temperature of hot water. So we had predicted that for this process to take place spontaneously, since there's a decrease in entropy when we form the solid, we should see a release of energy, and the increase in temperature confirms that that is indeed the case. Let's go ahead and do this one more time. This time we'll use a much larger test tube, and we'll zoom in so you can get a better view of what's happening. Go ahead and add that crystal again, and you can see the crystallization begins to happen very rapidly until it moves all the way down the test tube. Very cool. Now this is a fun variation on the demonstration. What I'm going to do this time is I'm going to pour a solution of the supersaturated sodium acetate onto the tabletop. So watch very carefully. There was a crystal already on the countertop, and as soon as the solution hit it, it immediately began to crystallize. If we're very careful, we can make a pretty tall column of the sodium acetate. Oh, that's a pretty good one. And as you can guess, lots of heat radiating off of that.